Research Network. I am Dr. Stephen. I'm a principal investigator and the MEG core director here at MRN. We are a nonprofit research organization focused on understanding brain function in order to help those with brain disorders. To achieve this mission, we use non-invasive functional neuroimaging tools such as magnetoencephalography and functional magnetic resonance imaging. We are recruiting children from the diverse state of New Mexico in order to understand brain development. We are particularly interested in understanding how adverse childhood experiences impact brain development. We believe that working together, parents, teachers, scientists, and caregivers, we can improve the outcome for all children. Please join us as we take you on a virtual journey.
You are now inside the Mind Research Network. Look at these happy participants, ready to help out science. And here we have Zinnia to go over the consenting process with the participants. During the consenting process, the research assistant will go over all aspects of the study. The RA will explain to you and your parent what you will be doing during the study, such as the MEG scan, the MRI scan, and some questionnaires and assessments. The RA will also go over the risks and benefits of the study, as well as go over how your information is protected at MRN. It is at this point where you and your parent will have the opportunity to ask any questions you may have. It is important that you have all the information you need to feel comfortable participating in the study. Once you and your parent have finished asking questions, you will sign the consent form which says that you understand what is going on with the study and that you agree to participate. Once you have finished signing the consent form, the RA will enter your information into the computer database. And now we'll head over to the first part of the study, the MEG. And here we have the MEG, which stands for magnetoencephalography. This records the magnetic fields produced by the electrical currents naturally occurring in your brain. However, before you sit in this chair, some preparation has to take place. The RA will be placing 5 electrodes on the participant. These electrodes will record heartbeats and eye blinks. In a real study visit, we would ask you to remove all metal from your person or clothes, as metal interferes with the readings from the MEG. In addition to the 5 electrodes, the RA will be placing 4 head position indicator coils, 2 on the forehead and 1 behind each ear. We call these HBIs, and they help us track your head movement inside the MEG. Once the HBIs are in place, you will wear these goggles that hold a receiver that communicate with a pen that will allow us to make a digital map of your head. The RA will now mark the position of the HBIs and trace the participant's nose and head. We use this information to align the MEG activity with the picture of your brain that we get from the MRI.
Can you pull your mask down just a tad for 1 second? Get your nose in your cheeks.
Once finished, we can see the outline of your head on the computer screen. Now it's time to finally get into the MEG. The MEG is kept in a magnetically shielded room. This room prevents electronic interference from disturbing the sensors. You will be given a response device that you will use to respond to the activities that you will be doing inside the MEG.
Okay, I'm going to slide your head up. What I want is the top of your head to hit the top of the helmet. Let me know when you're getting close, okay? Here we go.
We will raise you into the helmet as far as possible while remaining comfortable to ensure an accurate reading of your brain activity.
Up, do you have any room?
Yeah.
There is a camera and a microphone inside the MEG room. If you have any questions or concerns, please just speak up. The RA will set up the activities on the computer as you wait inside the MEG room.
Alright. So for this one, it's easy. Just 3 numbers are going to appear on the screen following the fixation cross. 2 of the numbers are going to be the same and one's going to be different. You're going to respond to the number that's different. So if there's 2 number 2s and a number 1, you're going to respond with your index finger number 1. If the number 2 is on its own, you're going to hit your middle finger, and number 3, your ring finger. Try it out. Here we go. Think you see me smile? You just messed up
After the MEG, we will remove the electrodes and the HBIs.
Yeah, that's messy. You're free to go. Stand up. Would you like a snack? Chicken.
Another part of the study is the MRI scan. You will lay down on the bed and be placed into the long tube. You will do activities similar to the ones you did in the MEG. You may also get the chance to watch some TV as we take pictures of your brain. MRI stands for Magnetic Resonance Imaging, and it uses a large magnet to create a strong magnetic field. This magnetic field, in addition to radio waves and a computer, allow us to create images of your brain, and it is all non-invasive. Once we have the brain activity from the MEG and the brain images from the MRI, we can use complex computer algorithms to map the activity of your brain. In this example, you can see the visual part of the brain lighting up as the participant responds to a visual task. Eventually, the brain will transfer the visual information to the front part of the brain, which you will see shortly. By mapping brain activity, we can decide if there are differences in timing in how typically developing children respond, and how children who may be affected by something such as ADHD may respond. By understanding brain function, we think that interventions can then be optimized to improve outcomes for children. You will finish out your visit in the assessment room, where you will do activities that will test your memory, attention, fine motor skills, and other areas.
Question now.